Welcome to This Explainer. Look, if you're a tech leader or an enterprise architect, you've seen the absolute explosion in AI capabilities recently. But taking those jaw-dropping demos from a sandbox and putting them into a secure, heavily regulated enterprise environment, yeah, that is a whole different ballgame. Today, we're going to bridge that massive gap between an impressive prototype and a truly reliable enterprise-grade production system.
Because here is the reality. Building AI agents for the enterprise is a rigorous software engineering discipline. It's not just an exercise in picking a model. Like the quote here highlights, the gap between a prototype and a production platform is literally the gap between a demonstration and actual engineering. The AI models themselves are practically commodities now. The real challenge, and honestly the real value, is entirely about how you architect, govern, and deploy them.
Okay, here's our roadmap for today. 1. What are enterprise agents? 2. Core architecture and components. 3. Enterprise agent design patterns. 4. Integrations, security, and governance. 5. The agent development process. And finally, 6. Overcoming AI production challenges. Let's dive in.
Section 1. What are enterprise agents?
Let's establish a baseline here because the term agent gets thrown around constantly. We all know traditional chatbots, right? They wait for a prompt, match it to some predefined intent, spit out text, and then usually completely forget who you are the moment you close the window. True enterprise AI agents are a totally different breed. They execute autonomous, goal-oriented workflows, they can reason, they plan out multi-step tasks, and they actively integrate with your external systems to get real work done, all while maintaining deep context across complex interactions.
And this autonomy escalates across a 4-level maturity spectrum. Down at level 1, you've got your basic RAG assistant. It retrieves and reads documents, which is great, but it can't actually do anything. Level 2 steps it up with single-step tool calls, like looking up a specific customer record. At level 3, things get serious. We're talking React agents that use our reasoning and acting loop to figure out multi-step goals. And finally, level 4 is the whole shebang, multi-agent systems, where a master orchestrator breaks down a massive task and delegates the pieces to specialized worker agents.
Section 2. Core architecture and components.
If we look under the hood, what does it take to make these agents actually reliable in production? Well, there are 3 non-negotiable layers. The LLM is basically just the engine, but an enterprise AI agent absolutely needs orchestration and reliability layers to act as the steering wheel and the brakes. Without all 3, your system will crash and burn. You've got to have that reasoning layer to plan things out. You need a secure tool execution layer so it can talk to your business apps safely. And crucially, you need that reliability layer to handle state management, catch API timeouts, and enforce hard limits so your agent doesn't just spin out into some infinite loop. Right inside that reliability layer is something called agentic memory, and it's an absolute game changer. It's what lets the system accumulate institutional knowledge. We're talking about in-context memory for the current task, episodic memory to recall past interactions with a specific user, semantic memory to pull up enterprise rules, and procedural memory, meaning it actually remembers successful ways to complete a task so it gets better over time. That is the difference between an AI that feels like a toy and one that acts like a seasoned veteran employee.
Section 3. Enterprise agent design patterns.
So how do we actually architect these? It turns out agent development is a highly structured discipline. With proven design patterns, you match the pattern to the workflow. For moderate stuff, the React loop is fantastic. If you have highly structured tasks where a human really needs to review the plan before anything executes, the plan and execute pattern is your best bet. Retrieval-augmented agents are perfect for compliance-heavy tasks that need strict data grounding. Human-in-the-loop literally pauses the agent to ask for permission. And for those massive enterprise workflows like employee onboarding, that multi-agent orchestrator pattern shines by delegating out all the heavy lifting.
Section 4. Integrations, security, and governance.
An agent is really only as useful as the tools it can access. Secure integrations with your CRMs, databases, and those clunky legacy platforms are essential. But obviously, giving an AI write access to your production database is terrifying if you don't have controls in place. So read operations have to be strictly scoped to user permissions. Write operations must be idempotent, which just means if the agent accidentally fires off the same command twice, it won't create a duplicate record. And internal legacy platforms, they should never be accessed directly. Put them behind a strict API gateway to keep things locked down. Which naturally brings us to the most critical question of all. When you're handing over the keys to your enterprise systems to an autonomous entity, how do we actually keep these agents safe? A zero-trust perimeter isn't just a best practice here, it is a hard mandate.
You absolutely have to prevent prompt injection so malicious inputs can't hijack the agent's logic. You need strict irreversibility controls, meaning any high-impact action, like wiring money or sending a mass email, is permanently blocked without explicit human approval. Human-in-the-loop escalation triggers are mandatory. And of course, every single action needs to be written to an immutable audit log for compliance. No exceptions.
Section 5. The agent development process.
Let's walk through the factory floor to see how these are actually built. It's a rigorous 6-phase life cycle. You start with discovery, asking, is this workflow even ready for automation? Then you select your architecture and build out your API tools before you even write a single prompt. Then comes agent development. But phase 5 is where it gets real. Evaluation. You aggressively red team the system, actively trying to break it. And when it comes to deployment, you don't just flip a switch. You run it in shadow mode alongside your human teams to compare the outputs. You want this thing making decisions in a sandbox long before it's making them in the boardroom.
Section 6. Overcoming AI production challenges.
Now for the reality check. Operating these autonomous systems in the wild is tough. Prototypes fail spectacularly if you don't engineer for the real world. Think about API rate limits. Without exponential backoff, an agent might hit a simple timeout and just endlessly retry, burning through thousands of dollars in API credits over your lunch break. Context windows overflow if they read too many documents. Multi-agent systems can have weird emergent failures. And if you lack deep system observability, your AI is essentially just a black box, and you'll have absolutely no idea why it made a catastrophic mistake.
So, here are the key takeaways to wrap this up. Picking an LLM is the easy part. Engineering the architecture around it is what actually dictates your scalability, your reliability, and your business value. Agents are autonomous, yes, but they require enterprise-grade architecture. Memory and secure tool orchestration are non-negotiable for performance. Security and audit trails are absolutely mandatory. And if you're in production, you need continuous observability. I want to leave you with this final thought as you map out the future of automation in your own company. Is your organization just building impressive demos, or are you actually engineering reliable AI? Are you stopping at the prototype, or are you putting in the rigorous architectural work required to make it survive in the real world? Thank you so much for joining me for this explainer. Keep learning and keep building with purpose.